Hi students, and welcome to this lecture which is on the topic percentages. Now, how many percentage marks did you get in your 10th standard? Or the percentage of total runs scored by Sachin Tendulkar in the World Cup 2011? Or what percent of total students in your class are boys? And these are some of the many questions that involve percentage. Percentage helps us to make a comparison or to understand the share of a particular entity in terms of the total amount. Now, as this is a very important chapter in quantitative aptitude, so here we will understand what are percentage, their fractional and decimal equivalents, the concept of percentage increase, decrease, successive increase and decrease, and also we are going to study about product constancy. And finally, through many solved examples, we will understand their applications in our day-to-day life. So, let's begin. First of all, let's try to understand the meaning of percent. When we use the word percent, what does it actually mean? Percent literally means for every 100. So, whenever we are using the word percent, it actually means that we are comparing a quantity with the base 100. Now, why does the word percent means for every 100? The percent can be divided into two parts, per and cent. And the meaning of cent is 100. So, for every 100. Thus, percent actually means for every 100 or out of every 100. We compare a quantity with respect to 100. Now, percent is always denoted by this symbol. So, this symbol always means that we are denoting a percentage. Now, what does 10% mean? 10% means 10 by 100. So, we have expressed 10 with respect to the base 100. So, always the denominator would be equal to 100. 10% means 10 divided by 100. Similarly, if I say 45%, it means that it is equal to 45 divided by 100. We have divided 45 by the base 100. If we say of 250%, then what does it mean? Definitely it is 250 divided by 100. So, whenever we use the symbol percent, it means that we are dividing this number by 100. The base is always considered to be 100. 5 is what percent of 20? We have to find out what percentage is 5 out of 20. So we can write 5 by 20 as equal to 5 into 5 divided by 20 into 5. We are actually trying to express the denominator as equal to 100. So this would be equal to 25 by 100. We have expressed 5 by 20 in a number such that the denominator is equal to 100. So 5 is 25% of 20. It actually means that if we take 5 parts out of 20, then that is actually equivalent to taking 25 parts out of 100. So we express in terms of 100. Now let us say that we have a company A which is selling computers, and similarly we have a company B which is selling soaps. Now if we say that in the first year the company A sells 1000 PCs and in the second year it sells 1100 PCs. And let us say that company B in the first year sells 1 lakh soaps and in the second year it sells 1 lakh 100 soaps. Now if we look at the increment, that is the increment in the number of products sold, then for both the companies that is equal to 100. 1100 minus 1000 is equal to 100, and similarly 1 lakh 100 minus 1 lakh is equal to 100. So both these companies have increased their number of products sold by 100. But now if I want to find out which company has performed better, then what do? We actually find out the percentage increment. So the percentage increase for company A is equal to 100 divided by 1000, as increase is 100 and the original number of PCs sold is equal to 1000. So this percentage increase is equal to 10% for company A. And for company B, that would be equal to 100, which is the increment, divided by the number of soaps sold in the first year, which is equal to 1 lakh. So that comes out to be equal to 0.1. So percentage increase for this company A is equal to 10%, and the percentage increase in the number of products sold for company B is equal to 0.1%. Now which is greater? Of course, company A has performed better in terms of increment in the number of products sold. Now it's very important for us to understand that whenever we have to find out the percentage increment, then we use the formula that percentage increment or the percentage increase is equal to absolute increase divided by the original number on which the increment has taken place into 100. So that would directly give you the percentage increase. And similarly, if we are to find out the percentage decrease, then decrease divided by the original number on which the decrease has taken place into 100. That would give percentage decrease. Now percent as a fraction. Now let's try to understand how to express percent as a fraction. A percent is equivalent to a fraction with denominator 100. We've already seen that a percent is actually equal to a fraction with a denominator 100. We always express the denominator as 100. So 8% of something would be equal to 8 by 100. Simply this sign means 1 by 100. So 8 by 100 of that thing. Now 8 by 100 is nothing but equal to 2 by 25. So that is equal to 2 by 25 of anything. Simply divide this number by 100. So that's the way how to convert a percent into fraction. Whenever you see this symbol, it means that divided by 100. The base has to be 100 or the denominator has to be 100. Now 13 by 25 is what percent? Now let's try to convert a fraction into a percent. Now what we have to do is we have to convert 13 by 25 into a percent. Now we always know that percent means denominator with 100. So what we are going to do is we are going to convert this denominator into 100. Now this could be done if we multiply and divide by 4. So 13 into 4 divided by 25 into 4. This is equal to 52 by 100, and so this is equal to 52%. So 13 by 25 is equivalent to 52%. Instead of multiplying and dividing by 4, what you can do is simply multiply the fraction by 100 and directly you can get the answer. So 13 by 25 into 100 would be equal to 52%. So whenever you have got a fraction and you want to convert it into percent, simply multiply it by 100. You'll get the answer in percentage. And if you want to convert a percent into fraction, divide it by 100. Now decimal as a percentage. Now let's try to see how to express a decimal into a percentage. To convert from a decimal to a percent, just move the decimal 2 places to the right or simply multiply the decimal by 100. So whenever you have to convert a decimal number into a percent, either move the decimal 2 places to the right, or in other words, multiply the number by 100. For example, 0.006 is equal to 0.06%. How? We simply move the decimal 2 places to the right. So 1, 2, 2. So 2 places would be at this point, and so it becomes 0.06%. Or if we multiply it by 100, 0.006 into 100, then that is also equivalent to 0.06%. So to convert a decimal into a percent, multiply it by 100. Now percent as a decimal. To convert from a percentage to a decimal, just move the decimal 2 places to the left or simply divide the percentage by 100. So what we do here is we move the decimal points to 2 places to the left, or we simply divide the percentage by 100. Example, express 3% in decimal. Simply divide the percentage by 100. So 3% is equal to 3 divided by 100, and this is equal to 0.03. So if you want to convert a decimal to a percent, multiply it by 100. If you want to convert a percent to a decimal, divide it by 100. Now estimating percents. Now at times it's difficult for us to calculate the exact value of percent. So in such cases what we do is we simply estimate percent. But before we do that, let's see some of the fractional equivalent of some simple percent. The first column gives us the percentage, and the second column gives us the fractional equivalent of such percentage. So 100% means 100 divided by 100, and that is equal to 1. 75% would be equal to 75 by 100 and equal to 3 by 4. Similarly, 50% means 50 divided by 100, and which is equal to 1 by 2. So 1 by 2 is equivalent to 50%. Similarly, 25% would be equal to 25 by 100, and which is equal to 1 by 4. 12.5% would be equal to 12.5 divided by 100, which is equal to 1 by 8. 20% would be 20 divided by 100 equal to 1 by 5. 10% is 10 divided by 100, which is equal to 1 by 10. 33.33% is equal to 33.33 divided by 100, which is equal to 1 by 3. So these are some of the fractional equivalent of some important percentage. Now based on this, let's try to estimate the percentage. Example, estimate 19 as a percent of 80. So we have to estimate 19 as a percent of 80. We do not have to find out the exact value, but we have to estimate. Now how to do that? 19 by 80 is approximately equal to 20 by 80. Though this is not equal to 19 by 80, but it would be approximately equal to 20 by 80. Now 20 by 80 is equal to 1 by 4, and from the table we see that 1 by 4 is equivalent to 25%. So 19 as a percent of 80 would be approximately equivalent to 25%. Thus 90 by 18 is equivalent to 25%. This is an estimated percentage. If we use the calculator and find out the exact value of 19 by 80 as a percentage, then that would be equal to 19 by 80 into 100, and this comes out to be equal to 23.75, which is nearly close to 25%. So if we have to find out a rough estimate, then we use the method of approximation, and using the fractional equivalent we find out the estimate percentage. Let's see one more example. Estimate 13% of 72. Again we have to estimate 13% of 72. Now 13% is approximately equal to 12.5%. Also we know that 12.5% is nothing but equal to half of 25%, and 25% is nothing but equal to 1 by 4. So this is equal to 1 by 2 into 1 by 4, which is equal to 1 by 8. Thus 12.5% is nothing but equal to 1 by 8. So 13% of 72 would be approximately equal to 1 by 8 of 72, and this is equal to 9. So the approximate value of 13% of 72 comes out to be equal to 9. Now if we use a calculator and find out the exact value, then that would be equal to 9.36, which is pretty much close to 9. So using the estimation, we can find out the approximate values of percentage. Let's see one more example based on estimation. Estimate 9.6% of 51. So we have to estimate 9.6% of 51. Now there are two methods. The first method is 9.6% of 51 is approximately equal to 9.6% of 50. Now we have rounded off the value of 51 to 50. This is equivalent to 9.6% of 50. Now 50 could be written as 100 by 2. So now this could be further written as 9.6% into 100 by 2, because 50 is nothing but equal to 100 by 2. 9.6% is equal to 9.6 divided by 100. 100 and 100 gets cancelled, and this would be approximately equal to 9.6 divided by 2. Now 9.6 divided by 2 is equal to 4.8. So the approximate value of 9.6% of 51 comes out to be 4.8. Here we have taken the approximate value of 51. Now the second method could be, we have approximated 9.6% to be 10%. So that would be equal to 10% of 51, which is equal to 5.1. Thus the approximate value of 9.6% of 51 is 5.1. From method 1 we get the approximate value as equal to 4.8, and from method 2 we get the approximate value as 5.1. But the actual value is 4.896. So this value, which is the exact value, is very much close to 4.8, the value which we found using method number 1. So in this case, first method is better, as it gives us a value which is very much close to the actual value. So instead of using method 2, we should use method 1 in such cases. Actually, approximating 9.6% to 10% is by large a very huge approximation which we should avoid. So this was about estimating percentages. Now let's see percentage increase and percentage decrease. Percent increase and decrease of a value measure how that value changes as a percentage of its original value. So whenever we say of percentage increase or percentage decrease, then it means the measure that how much of value changes with respect to the original value as a percentage. So percentage increase or decrease helps us to measure how much the value of any quantity changes with respect to the original quantity or with respect to the original value. Your important thing is that it is always expressed in terms of its original value or the original quantity. Percentage change would be equal to absolute value change divided by original quantity into 100. we are multiplying it by 100 because we are trying to find out the percentage change. So percentage change is equal to absolute value change divided by the original quantity into 100. Now this percentage change could be a percentage increase or a percentage decrease. If the case is percentage increase, then absolute value change would be actually the increment that has taken over the original value divided by the original value into 100. And if we are trying to find out the percentage decrease, then this would be equal to decrease divided by the original quantity. The important thing is that the base should be original quantity. For example, let us say that we have a series of comic books. Now in the year 1994, the price was 120 rupees. This comic book was priced at 120 rupees in the year 1994. But in the year 1995, the price changed to 132. Now if I ask you what is the absolute change in the value, then that would be equal to 132 minus 120, which is equal to 12 rupees. So the absolute value change would be equal to 12 rupees. We simply subtract the original value from the new value, and the original value is 120. Now if I ask you what is the percentage change in the value, then that would be equal to 12 divided by 120. 12 is the absolute value change and 120 is the original value. So 12 by 120 into 100, which is equal to 10% increase. There is a 10% increase in the value of the comic book from the year 1994 to the year 95. Let's take one more example. Amy is training for the 1500 meter run. When she started training, she could run 1500 meters in 5 minutes and 50 seconds. After a year of practice, her time decreased by 8%. How fast can she run the race now? So in this example, Amy, who is an athlete, is training for 1500 meter run. Initially, she could run 1500 meters in 5 minutes and 50 seconds. After a year of practice, her time decreased by 8%. Now we have to find out how fast can she run the race now. So total distance is equal to 1500 and the time taken is 5 minutes 50 seconds, which is equal to 350 seconds. We convert this minute into seconds, and so we get the total time taken to be equal to 350 seconds. Now her new time decreased by 8%, given that through practice she decreased her time by 8%. So the decrease in time would be 8 by 100 into 350. 350 is the original time taken. So the decrease, the absolute decrease would be equal to 8 by 100 into 350, or which is equal to 28 seconds. Now new time would be original time minus the decrease that happened in the time. So that would be equal to 350 minus 28, which is equal to 322 seconds. Now if we convert it into minutes, then we get the answer as equal to 5 minutes 22 seconds. So the new time is equal to 5 minutes 22 seconds, and which is 8% less than the original time taken by Amy. Now by what percent is her earlier time more than her present time? Now we have to find out by what percent her earlier time is more than her present time. That there is a decrease in 8%, so the answer should be 8%. But no, the answer is not 8%. Why? Because now we have to find out with respect to the new time, not with respect to the original time. Earlier we had given that 8% is the decrease in time with respect to her original time. Now it is asked by what percent is her earlier time more than her present time. So the base has changed now. The base is now the present time, not the original time. So difference is 28 seconds, as we have already found. And so the base here is 322 seconds, that is the new time, and not 350 seconds. So the percentage change would be 28, that is the decrease, divided by 322, which is the new time, into 100, and this comes out to be equal to 8.69%. So her earlier time is 8.69% more than her present time. So students, this is a very important example through which you have to understand what base has to be taken, because at times it's very confusing and we take the original base all the time for calculating the percentage change. But the language of the problem has to be very clearly understood. If it is asking about a percentage increase or decrease with respect to the original value, then the base would be the original value. But if it is about percentage increase or decrease with respect to a new value, then the base has to be the new value. So before solving, please try to understand and please comprehend the language of the problem, which base it is talking about. Let's see one more example. If 5 increases by 10%, what is the new value? So we have the number 5 and this value increases by 10%. What is the new value? First of all, we are going to find out 10% of 5. Now 10% of 5 is nothing but 10 divided by 100 into 5, which is equal to 0.5. So now this value 5 is to be increased by 0.5. So we will increase 5 by 0.5 and so the new value would be equal to original value plus the increase. Original value is 5 and the new value increase would be 5 into 10 by 100, this expression, which is equal to 0.5. So the answer would be 5.5. Now we can also write this as new value equal to 5 into 1 plus 10 by 100. Here 10 is the percentage increased. So the new value would be 5.5. If A increases by R%, then the increased value would be given by A into 1 plus R by 100. So this is the expression for finding the new value. That is, if A increases by R%, then the new value A dash would be equal to A into 1 plus R by 100. Similarly, let's try to solve one more example. If 5 decreases by 10%, what is the new value? Now we are going to decrease 5 by 10%. We have to find out the new value. Then again 10% of 5 is nothing but equal to 0.5, 10 by 100 into 5. Now this has to be decreased from 5. So the new value would be equal to original value minus the decrease. So 5 minus 5 into 10 by 100. This could be written as 5 into 1 minus 10 by 100. Now this expression is nothing but equal to 0.9. So 5 into 0.9 is equal to 4.5. Or this could also be written as 5 minus 0.5, which is also equal to 4.5. So the answer would be the new value is equal to 4.5. So in general, if P decreases by R%, then the decreased value is given by B into 1 minus R by 100. Whenever there is a decrease, there is a minus sign over here, and if it's an increase, there's a plus sign over here. So this is about the percentage increase and percentage decrease. Now based on percentage increase and decrease, what we have just studied, let's try to solve a few examples. The problem says that two numbers are respectively 20% and 50% more than a third number. What percentage is the first of the second? So this problem says that there are two numbers. The first is 20% more than the third number and the second number is 50% more than the third percent. We have to express first number as the second number in terms of percentage. So let's try to see the solution. Let us say that the third number is equal to 100. So let us assume that the third number is 100. Why we have assumed the third number to be 100? That is for the convenience of it. So the first number would be equal to 20% more than the third number. Now the first number is 20% more than the third number. So that would be equal to 100 into 1 plus 20 by 100. We have used the formula for percentage increase. Now 1 plus 20 by 100 is nothing but equal to 1.2. So 100 into 1.2 is equal to 120. So the first number is equal to 120. Similarly, let's calculate the second number. Second number is equal to 50% more than the third number. Again, we are going to use the percentage increment formula, which is 100 into 1 plus 50 by 100. Now 1 plus 50 by 100 is equal to 1.5. So 1.5 into 100 equal to 150. So we get the first number equal to 120, second number equal to 150 when we have taken the third number to be 100. Now first as a percentage of second would be equal to first number divided by the second number into 100. Because we have to express the first number as a percentage of second, so the base or the denominator has to be the second number and the numerator would be the first number. So first number is 120, the second number is 150. Substituting these values in this formula, what we get? 120 by 150 into 100. This gives the value as equal to 80%. So the first number as a percentage of the second number would be equal to 80%. So first number is 80% of the second number. In many of the problems on percentages, we take the assumption to be 100 because it makes the problem very easy. Doing calculations with 100 becomes very easy. So that is why we assume the value to be 100 at times. Let's solve one more example. A positive number is divided by 5 instead of being multiplied by 5. So what percent is the result of the required correct value? So in this problem, a positive number is divided by 5 instead of being multiplied by 5. So a number should have been multiplied by 5, but by mistake it is being divided by 5. Now we have to express the result obtained in terms of percentage with respect to the correct value. So once again, let's look at the solution. Let us assume that the original positive number is equal to x. Now the correct answer should have been 5x because we should have multiplied this number by 5. So the correct answer is 5x. But what we have done is we have divided it by 5. So the incorrect answer is 1 by 5 of x, or x by 5. So the correct value is 5x, the incorrect value is 1 by 5x. So the required percentage is equal to x by 5 divided by 5x into 100. X and x gets cancelled, and what we get is 100 divided by 25, which is equal to 4%. So the incorrect answer with respect to the correct answer in terms of percentage is equal to 4%. Now we shall see what happens when successive changes are made to a quantity. Let's try to understand this through an example. A trader gives successive discounts of 10%, 20% and 25% respectively. Calculate the overall discount given by the trader. So this problem says that a trader gives successive discounts of 10%, 20% and 25% respectively. Successive means first the trader gives a discount of 10%, then on that amount he again gives a discount of 20%, and finally on the final amount he gives again a discount of 25%. We have to calculate the overall discount given by the trader. So we have to calculate one equivalent discount that is equal to these three successive discounts. So let us say that the marked price of an article is equal to 100 rupees. To make our things simple, we assume the marked price of the article to be rupees 100. So initial price that is marked by the trader is equal to 100 rupees. Now the trader gives a discount of 10% on this marked price 100. So 10% of 100 would be equal to 10 rupees, and so we subtract 10 rupees from 100 and get the answer as 90. So after a discount of 10%, the price reduces to 90 rupees. Now again the trader gives a discount of 20%. So 20% of 90 would be equal to 18 rupees, and when we subtract this 18 from 90, we get answer as 72. So the next price becomes 72 rupees after a discount of 20% on this marked price 90 rupees. So we get the new marked price as 72 rupees. But the trader finally gives a discount of 25% again on this marked price, which is 72. So a reduction of 25% on 72 would be equal to 18 rupees, and when we subtract it from 72, we get the final marked price as equal to 54 rupees. So initially the marked price was 100, but the final price after three successive discounts of 10%, 20% and 25% gets us a final marked price of 54 rupees. So what we can say is the overall discount given by the trader is equal to 100 minus 54, which is equal to 46. As we have taken the original marked price to be 100, so 46 by 100 into 100 would be equal to 46%. So we can say that the three successive discounts of 10%, 20% and 25% is actually equivalent to a single discount of 46%. And this is what is successive changes. That is, a number is increased or decreased in succession. Let's take one more example. In a library, 20% of the books are in Hindi, 50% of the remaining books are in English, and 30% of the remaining books are in French. The remaining 6,300 books are in regional languages. What is the total number of books in the library? So in this problem we have been given that there is a library and there are a number of books in that library. 20% of the books are in Hindi, 50% of the remaining books are in English, 30% of the remaining books are in French, and the books finally left are 6,300 in number, and they are in regional languages. we have to find out the total number of books in the library. So let's look at the solution of this problem. Let us say that the number of books in the library is equal to y. So let's assume that the number of books is equal to y, and finally we are going to find out the value of y. The books in Hindi would be equal to 0.2y because the books in Hindi are 20% of y, which is equal to 0.2y. So the books other than Hindi would be 0.8y. Remaining books would be y minus 0.2y, which is equal to 0.8y. Now it is given that English books are 50% of the remaining books. So that would be equal to 0.5 into 0.85, as 50% is equal to 0.5. So we multiply this by 0.5. So remaining books would be 0.85 minus 0.5 into 0.85, which is actually equal to 0.5 into 0.85. So these are the books left. Now of these books, given that 30% of the books are in French, so the books in French would be 0.3 into 0.5 into 0.85, as 30% is equal to 0.3. So the remaining books would be 0.7 into 0.5 into 0.85. So the books which are finally remaining are 0.7 into 0.5 into 0.85, but these are equal to 6,300 in number because these are the books which are in regional languages, and so we equate 0.7 into 0.5 into 0.85 with 6,300. And finally, through this equation we get the value of y equal to 22,500. So the total number of books in the library comes out to be equal to 22,500. So the total number of books in the library comes out to be equal to 22,500. Earlier we have seen what happens when there is a percentage increase or decrease with respect to a quantity. Now let us say that there is a quantity which is related to some other quantities through their product. What is the effect on the product when these two quantities are either increased or decreased? So let's understand the percentage change in the product change. Let's try to understand it through an example. The length and breadth of a rectangle are 10 cm and 5 cm. Now if the length becomes 12 cm and the breadth becomes 7 cm, then what is the percentage changed in the area of a rectangle? So let us say that we have a rectangle such that the length of this rectangle is equal to 10 centimeters and the breadth is given by 5 centimeters. Now it so happens that the length becomes 12 centimeters and the breadth becomes 7 centimeters. There is an increase in the length as well as the breadth. We have to find out the percentage change in the area of the rectangle. Let's try to understand it. The initial area of the rectangle would be 10 into 5, which is 50 centimeters square. Now the initial length is equal to 10 centimeters. Final length is equal to 12 centimeters. Now if I ask you what is the percentage change in the length, that would be equal to 2 by 10 into 100. Why? Because there is a change of 2 units in the length and the original length is 10. Therefore 2 by 10 into 100 would give us a percentage increase in the length of this rectangle, and that comes out to be equal to 20%. So the length of the rectangle has increased by 20%. Similarly, the initial breadth is equal to 5 centimeters and the final breadth is equal to 7 centimeters. Now what is the percentage change in breadth? That would be equal to 2 by 5 into 100. Change is equal to 2 units and the initial breadth is equal to 5 units. So 2 by 5 into 100, which comes out to be equal to 40%. Thus the length increases by 20% and breadth increases by 40%. Now we are going to find out what is the overall effect on the area of the rectangle. So both these quantities have increased. So what is actually the effect on the area, or what is the percentage increase in the area of the rectangle? Let us say that the area of the rectangle is equal to 100. Now there is an increment of 20% because the length increases by 20%, so the area should also increase by 20%. This becomes equal to 120. Now we have also seen that the breadth increases by 40%. So again we are going to make an increment of 40% on this quantity 120. So the increment of 40% or the 40% increase in 120 would be equal to 168. So the final value of the area becomes 168 when the initial area is equal to 100. So what is the percentage change in the area? Definitely this percentage increase is equal to 168 minus 100, which is equal to 68 divided by 100 into 100, which finally comes out to be 68%. So finally we can say that the area of the rectangle has increased by 68%. In this particular case, the length increased by 20% and the breadth increased by 40%. But when we look at the overall area, then we see that the overall area has changed by 68%. So based on this, let's see a very important formula, and it says that if a quantity first increases by A% and again it increases by B%, that is a successive increase, then the overall percentage change is given by the formula percentage change equal to A plus B plus A into B divided by 100. So this is a formula that gives us the overall percentage change when a quantity first increases by A% and again it increases by B%. The important thing to note here is if there is an increase, then it should be substituted with a positive sign, and if there is a decrease, then it has to be substituted with a negative sign. For example, if the quantity increases by A% and it decreases by B%, then we are going to place a minus sign over here and a minus sign over here because A into B would be negative. So the overall formula would be then A minus B minus A into B by 100. So remember that a minus sign has to be placed when there is a decrease. So just remember that in this very formula, if a quantity is decreasing, then the percentage would be negative. So based on this, let's try to solve an example. The salary of a worker is first increased by 10% and thereafter it was reduced by 10%. What was the change in his salary? So first, the salary of the worker increases by 10% and later on it decreases by 10%. We have to find out the overall change in the salary. So let's again see the solution. Might be you must think that there is an increase of 10% and then there is a decrease of 10%. So there shouldn't be any effect on the salary. But that's not true. Why? Let's try to see that. Let us say that the initial salary is equal to S. Now first there is an increment of 10% on the salary. So let us say that the new salary becomes S dash, and finally there is a decrease or a reduction of 10% in this salary, and let us say that the final salary becomes S double dash. Now is the initial salary equal to the final salary S double dash? Let's try to find this out. We have seen the overall percentage formula, and that is A plus B plus AB divided by 100, and if there is a decrease, then it has to be replaced by a negative sign. Your A becomes 10 and B becomes minus 10. So your A would be equal to 10 and B would be equal to minus 10. We substitute these values in this formula, we get 10 minus 10 plus 10 into minus 10 divided by 100. This and this gets cancelled and this is actually equal to minus 1. So we see that the overall percentage is equal to minus 1%. What does minus represent? Minus represents a decrease. So we can say that the final salary is 1% less than the initial salary. So actually in this very process we have seen that there is a reduction in the final salary of the person. That is a loss to the employee. So this was a concept of successive change. How the quantity changes when there are successive changes, successive percentage increase or decrease with respect to the original quantity. Now let's try to understand what is product constancy. Earlier we have seen that if we have got a quantity which is dependent on the product of two quantities, and we have seen how this product changes when both these quantities are changed. But now we are going to change this problem. Let us say that again the product P is equal to A into B, where A and B are two quantities and P, which is the third quantity, is equal to A into B. Now let us say that A is changed. We have to find out what should be the percentage increase or decrease in B so that the product P remains constant. Let's try to understand it through an example. Let us say that the length of a rectangle increases by 10%. And by what percent should the breadth decrease so that the area of the rectangle remains constant? Earlier we have seen that the length and breadth both are increased, and we have seen what is the overall effect on the area of the rectangle. But now is a twisted problem. We say that the length of a rectangle is increased by 10%. We have to find out what should be the percentage decrease in the value of breadth so that the area of the rectangle remains constant. The point is, the area remains the constant, the product remains the constant. So let's try to see the solution. Let us say that the area of rectangle is equal to 100. So let us assume that the area of the rectangle is equal to 100 and it has to remain constant throughout. So the initial area is 100. Now we see that the length increases by 10% and so the area would increase by 10%. This would be equal to 110. So the new area becomes 110. But now we have to keep the area constant and that should be equal to 100. Now what quantity should be subtracted from 110 so that it comes back to its original value, which is 100? Definitely that is equal to minus 10. We are actually subtracting minus 10 from 110 so that the value becomes equal to 100. So the final area would be 100. Now we see that this part which brings back 110 to 100 is because of the change in the breadth. And so we can say that the percentage change would be, the change is 10, we have reduced it by 10 divided by 110. Now why we have taken 110? Because the base here is 110. We are actually subtracting 10 from 110. So the base would be 110 into 100 and this gives the value as 9.09% approximately. So the breadth of the rectangle should decrease by 9.09% so that the area of rectangle remains constant. Once again, what we have done is, first we have increased the area by 10% because the length increases by 10%. So that would be equal to 110. Now to again get back the value of 100, we have to reduce this value by 10. So we reduce this value by the number 10. When we look at the percentage change that happened, that would be equal to 10 divided by 110 because this becomes the base now. We are reducing 10 from this number 110, not 100. And so the percentage change would be 10 divided by 110 into 100, which is equal to 9.09%. This is how the product remains constant. Based on the above principle of product constancy, let's try to solve an example. The price of rice increases by 20%. By how much percentage the consumption of rice has to be reduced so that the overall expenditure on rice remains unchanged? So this is very much similar to the previous problem. Here we have the expenditure which depends on the price of the rice and on the consumption, that is how much quantity of rice is being consumed. So given that due to inflation the price of rice increases by 20%, we have to find out how much percent there has to be a decrease in the consumption of rice so that overall expenditure on rice remains the same. So let's look at the solution. Let us say that the expenditure on rice is equal to 100. Again, we are going to assume that the expenditure or the product is equal to 100. So this is the expenditure. Now, first of all, the price of the rice changes by 20%. So there is an increment of 20% on 100. This would be equal to 120. This quantity becomes 120. 20% rice in 100 is equivalent to 120. The expenditure now becomes 120 rupees. According to the problem, the expenditure on the rice should remain the same, that is, it should be 100 again. So we see that the value should be changed by 20 or decreased by 20. So 120 minus 20 would give the final value as 100, which is the expenditure. It has to remain the same, that is, initial and the final expenditure on these successive changes must finally result into the same expenditure. So now this decrease is due to the percentage decrease in consumption, and so here again the important thing is the change is equal to 20 and the base would be here 120 because the change is actually taking place on this number 120. And so we can say that the overall change or the percentage decrease in the consumption of rice would be equal to 20 divided by 120 into 100, which is equal to 16.67%. So the consumption of the rice should be decreased by 16.67%. This is the method of solving problems based on product constancy, that is, the product should remain constant. And this is the most easiest way of solving such problems. Now this chapter is so much important as far as data interpretation is concerned. So many data interpretation questions revolve around the concept of percentage. And in the examination, we don't have calculator. So let's see how to calculate the rough value of percentages. Might not get the accurate result, a result that is very much close to the original answer. So if I say that, what is the percentage value of 53 by 74? We have to express this as percentage. Option number A is 67%, option B is 71.6215%, option C is 75.25%, and option number D is 78.29%. Now this is a problem in which we have to find out the percentage value of this fraction, and we have been given the 4 options to solve this. Let's see the solution of this. The percentage value of 53 by 74 is nothing but equal to 53 by 74 into 100. We simply multiply this fraction by 100. Now 53 by 74 could be written as equal to 37 plus 60 divided by 74. Actually, half of 74 is equal to 37, so that would be equal to 37 plus 16 by 74. Further, this could be written as 37 by 74 plus 16 by 74. Now 37 by 74 is nothing but equal to 1 by 2, which is actually equivalent to 50%. So 37 by 74 is equal to 50% plus 16 by 74. Now we have to find out what is the value of 16 by 74 in terms of percentage. Now 16 by 74 could further be written as 7.4 plus 8.6. So that would be equal to, this is 50% plus 7.4 divided by 74 plus 8.6 divided by 74. Now clearly 7.4 by 74 is equal to 1 by 10, which is equal to 10%. So this further becomes 50% this plus 10% this plus 7.4 by 74 plus 1.2 by 74. Again we have expressed 8.6 as 7.4 plus 1.2. So this finally becomes 50% plus 10% plus 10% because of this, plus 1.2 could be further written as 0.74 plus 0.37. So 0.74 divided by 74 plus 0.37 divided by 74 plus 0.09 divided by 74. This could further be written as 50% plus 10% plus 10% plus percent. This quantity 0.74 by 74 into 100 would be equal to 1%. Similarly, 0.37 by 74 would be equal to 0.5%. And again we can write 0.09 as 0.074 plus 0.016 by 74. This becomes 50 plus 10 plus 10, that is 70, 70 plus 1, 71, plus 0.5, 71.5, plus that would be again 0.1. So this overall percent would be 71.6%. Actually what we are doing is we are breaking it into percentages and then finally adding them to get the required answer. Just try to make the numerator in terms of multiples of denominator so that we get some standard percentage equivalents. Eventually if we add all these percentage equivalents, what we get is the final answer. This is the way how we calculate the percentage values in our exams. We don't have a calculator over there and we follow the simplest trick to calculate the percentages. Let's try to solve an example. A solution of salt and water contains 50% salt by weight. Of it, 30 kg solution evaporates and the solution now contains 20% of salt. Find the original quantity of solution. So this problem says that we have a solution of salt and water in which there is 15% salt by weight. It means that if we have a 100 kg solution, then 15 kgs would be salt and the remaining 85 kgs would be water. Now of this solution, 30 kgs evaporate and the solution now contains 20% of salt. Remember that when evaporation takes place, only the water evaporates. Salt is left behind. So out of these 30 kg solution, only the water has evaporated. The salt has remained into the solution. Now of course the concentration of this solution would increase and this becomes 20%. Now we have to find out the original quantity of the solution. So let's look at the solution of this problem. Let us suppose that there was x kg of solution initially. Let us say that the solution is equal to x kgs initially. The quantity of salt in this solution initially is equal to 15% of x, which is equal to 15x by 100, or we can write it as 3x by 20 kgs. So the absolute quantity of salt in the solution is equal to 3x by 20 kgs. Now after evaporation, the solution left behind would be x minus 30 and the salt content would be 3x by 20. This is because the salt would remain as it is, so it won't evaporate, but the solution would reduce by 30 kgs because water has evaporated. So the final solution would be x minus 30 kgs and the salt content would be 3x by 20. But this new solution contains 20% of salt. 20% of x minus 30 should be equal to 3x by 20. 20% of x minus 30 is the quantity of new solution would be equal to 3x by 20, which is the salt content. This becomes x minus 30 by 5 equal to 3x by 20. This could be further written as 4x minus 120 equal to 3x, or x equal to 120. Thus, the original quantity of solution is equal to 120 kgs. So thus we can say that the original quantity of solution is equal to 120 kgs. Let's see one more example. Weights of two friends Ram and Shyam are in the ratio of 4:5. Ram's weight increases by 10% and the total weight of Ram and Shyam together becomes 82.8 kg with an increase of 15%. By what percent did the weight of Shyam increase? Option number A is 12.5%, option number B is 17.5%, option C is 19%, option D is 21%, and option number E is none of these. So in this problem we have been given two friends Ram and Shyam and their weights are in the ratio of 4:5. Now Ram's weight increases by 10% and the total weight of Ram and Shyam together becomes 82.8 kg with an increase of 15%. Actually, Ram's weight has increased by 10% and we do not know by how much amount has Shyam's weight increased. But we know that they together now weigh 82.8 kgs and this 82.8 kg is actually an increase of 15% on the original combined weights of Ram and Shyam. We have to find out the percentage increase in the weight of Shyam. So let's see the solution. Given to us is that the weights of Ram and Shyam are in the ratio of 4:5. So let us say that the weights of Ram and Shyam be 4x and 5x. As they are in the ratio of 4:5, so let us say that the weights are 4x and 5x. Also, the total weight increases by 15%. So 4x plus 5x into 1.15 would be equal to 82.8. The initial combined weight would be 4x plus 5x, and if we add 15% on this initial weight, we get the final weight as 82.8. So we get the equation as 4x plus 5x into 1.15 equal to 82.8. This gives the answer as x equal to 82.8 divided by 1.15 into 9, which is equal to 8. Thus the value of x is equal to 8. So Ram's new weight would be 4x into 1 plus 10 by 100 because the weight of Ram has increased by 10%. This gives 4 into 8 into 1.1, which is equal to 35.2. So Ram's new weight would be 35.2. Now Shyam's new weight would be 82.8 minus 35.2 because Ram's new weight and Shyam's new weight is equal to 82.8. So if we subtract this quantity from 82.8, we get Shyam's new weight, which is equal to 47.6. Now Shyam's new weight is equal to 47.6. Shyam's original weight is equal to 5x. The value of x is equal to 8. So 5 into 8 is equal to 40. So Shyam's original weight is equal to 40. Shyam's new weight is equal to 47.6. Therefore, the percentage increase in Shyam's weight would be equal to 47.6 minus 40 divided by 40 into 100, which is equal to 19%. And so we can say that option number C is correct. So just using the simple concept of percentage, we have solved this problem. So this was all about our lecture on percentages. Percentage forms the very basis of quantitative aptitude. So it forms a very crucial part of our studies. This is also a very simple chapter, but at the same time very important. So try to practice as many problems you can find on this chapter. Further, if you have doubts, you can visit our website, that is www.TopCoaching.com. Also, for more theory and practice tests, you should visit our site. Thank you.